Now, this chapter is very important chapter because it will give you the basic idea required for cardiovascular system. Once you understand adrenergic stimulants, you will be able to understand beta blockers. Then when you understand beta blockers and you know the limitations of beta blocker, adverse drug reactions of beta blocker, side effects of beta blocker, you develop the new group from it, that is calcium channel blockers. Once you know the limitations of calcium channel blocker, you develop the new group from the same, that is ACE inhibitors. What I mean to say, for all these drugs, the basic group, the basic all fundamental understanding, physiological understanding, that is what is required, is from this chapter. Adrenergic stimulants. I will go through the adrenergic and cholinergic nervous system first because that is a very fundamental part every student must understand. Should I start? Now, do remember fundamentally autonomous nervous system is divided into adrenergic nervous system and cholinergic nervous system. If you take nervous system first, then the principal division is CNS and ANS. PNS is for our understanding, proper understanding. PNS is for our proper understanding. Principal division is ANS and CNS. In that CNS, all of you know, it's brain and the spinal cord. And in ANS, it is principally divided into the sympathetic nervous system and parasympathetic nervous system. Now, my point is very important. There is a chain of ganglion running parallel to the spinal cord. There are 31 ganglions. My point is important. There are 31 ganglions running parallel to the spinal cord. The system, the part of the autonomous system which is developed, taking them into consideration, is known as sympathetic nervous system. Getting my point? Now, there are some cranial nerves along with some sacral nerves, S2, S3 and S4. They constitute another system and that system is known as cholinergic nervous system. That is parasympathetic nervous system. पहिल्यांदा मी म्हटलं sympathetic nervous system. Second is parasympathetic nervous system. Mask. Parasympathetic nervous system is related with the cranial nerves. Are you getting my point? First we have started with the nervous system, then autonomous nervous system, then division of autonomous nervous system. Are you getting my point? Yes. Now, one very fundamental thing I must tell you, and that is the adrenergic nervous system or the sympathetic nervous system. See, sympathetic nervous system is also known by the name adrenergic nervous system. The parasympathetic nervous system is also known by the name cholinergic nervous system. The system which is developed out of the chain of ganglions running parallel to the spinal cord is known as sympathetic nervous system, is also known by the name adrenergic nervous system. The part of the autonomous nervous system that considers the ganglions related to the cranial nerves as well as the sacral nerves is known as parasympathetic nervous system. This parasympathetic nervous system is also known by the name cholinergic nervous system. Do remember, adrenergic and cholinergic are physiological concepts. Sympathetic and parasympathetic are anatomical concepts, but they go hand in hand. Are you getting my point? Yes. Adrenergic nervous system is equal to sympathetic nervous system. Cholinergic nervous system is equal to parasympathetic nervous system. Now, point is very important. If you consider adrenergic nervous system or sympathetic nervous system, its response is fight or flight. Its response is fight or flight. Whenever something happens, wrong happens, you either fight with it or you go away from the place. that immediate decision need to be taken by the system, and that is sympathetic nervous system. Adrenaline comes into play. Where exact opposite to this is a cholinergic nervous system, is a parasympathetic nervous system. That is rest and digest. Dominance of parasympathetic nervous system or cholinergic nervous system is related with rest and digest. Rest and digest. When you are very calm, the dominant effect will be of cholinergic nervous system. When you are in stress, the dominant effect will be of sympathetic nervous system. That is adrenergic nervous system. Sympathetic, adrenergic. Parasympathetic, cholinergic. But these systems are antagonistic in their function. Both the systems are antagonistic in their function. Now, most of the visceral organs, point is very important. Most of the visceral organs are supplied by both of these systems. Now, generally, point is important, generally, sympathetic nervous system is stimulatory in its function. Sympathetic nervous system, that is adrenergic nervous system, is stimulatory in its functions. Most of the time, this is a true sentence. And the cholinergic nervous system or the parasympathetic nervous system is generally inhibitory in its function. When that system gets stimulated, the function of the organ concerned reduces. Which system reduces the function when stimulated? Parasympathetic. Sympathetic increases the function. In simple language, most of the time, the adrenergic nervous system is stimulatory in its function and the cholinergic nervous system is inhibitory in its function. Stimulation of adrenergic nervous system increases the function of the organ concerned. Stimulation of cholinergic nervous system decreases the function of the organ concerned. This thing you should keep it in mind. Are you getting my point? Now I will read something because what will happen, he mage raun jail. Getting it? Yes. Introduction to adrenergic stimulants. The drug which bring about the stimulation of the sympathetic nervous system are called as adrenergic stimulants. Am I right? The drugs which will bring about the stimulation of adrenergic nervous system, that is sympathetic nervous system, will be called as adrenergic stimulants. Major member of the group are adrenaline, noradrenaline, isoprenaline, dopamine, dobutamine, ephedrine, salbutamol. Many are there. These all are adrenergic stimulants. They are having their groups and all that I will go into detail. Am I right? Yes. Now, this is a very important point. And that is adrenaline, noradrenaline, isoprenaline and dopamine or dopamine. These are the 4 drugs known by the name catecholamines. These are known by the name catecholamines because they are having one catechol nucleus. They are having 2 OH groups attached to it. When a single OH group is attached to a benzene ring, we call it phenol. When one OH group is attached to the benzene ring, we call it phenol. When 2 are attached, we call it catechol. We call it catechol. And that's why the name given is catecholamines. Now, this fellow is thinking, Dr. Joshi, why you are putting so stress on this catechol? Because, my dear students, this catechol nucleus is susceptible to an enzyme known as COMT. COMT is an enzyme present in the liver. COMT stands for catechol O-methyl transferase. Catechol O-methyl transferase. Catechol O-methyl transferase is the enzyme present in the liver, and that catechol O-methyl transferase 100% degrade this catechol nucleus. It acts upon it and degrade it. Now my point is important. Whenever you are using any of these drugs, can you use them orally? adrenaline, noradrenaline, dopamine, isoprenaline. Can you give them by oral route? If you give them oral route, even though absorption takes place, they will move to the liver. They will move to liver and they will be 100% degraded because liver is very rich in COMT. Very rich in this COMT. Catechol O methyl transferase is abundantly present in the liver, and that is the reason if you are using these drugs by oral route, practically you will get zero bioavailability. The drug will not going to enter the systemic circulation, and that is the reason these drugs are available only by parenteral route. You will never get a tablet of adrenaline. You will never get a tablet of isoprenaline. Getting my point? Actually, isoprenaline tablets are available, but those are sublingual. Those are sublingual. You will never get a tablet of dopamine. Are you with me, my dear student? Why? Because their chemical structures are having this molecule. This is an integral part of their molecular structure. And this is susceptible to an enzyme which is abundantly present in the liver, and the enzyme is COMT. Catechol O methyl transferase is present in the liver that degrades this drug 100%. And that's why these drugs cannot be given by oral route. They are to be given only by parenteral route. So this is a very important thing that every student should note the point. Liver degrades this catechol nucleus and hence cannot be given administered by oral route. The adrenergic receptors are divided into alpha and beta. This is the catechol nucleus. Actually, it should be at 3 and 4 position. Actually, it should be in 3 or 4 position. If you are having this one, it should be at 3 and 4 position. This is the right one, which I made earlier. But okay, not a problem. Now, I am going to tell you about the adrenergic and cholinergic nervous system, some basic consideration, which I already made a comment. Let us see. Nervous system coordinates all the different systems of the body. Do you agree with me? Yes. It is principally divided into CNS and NS. Some consider PNS as a part of nervous system, but it is the combination of CNS plus NS. CNS can again divided into brain and spinal cord, where NS is divided into sympathetic and parasympathetic nervous system. Now, we want to consider that sympathetic nervous system, and for that, we are going in detail. This picture will give the best possible idea. This picture will give the best possible idea. What is this picture? This is the chain of ganglions. You can see the chain of ganglion. This is a chain of ganglion running parallel to the spinal cord. This is sympathetic trunk. Are you getting my point? Yes. In Yoga Shastra or Ayurveda, we call it Ida and Pingala Nadi. That Ida and Pingala are these one. They are running parallel to the spinal cord. Now, you can take any organ. Every organ is having supply by this sympathetic trunk. You take any visceral organ or even some organ from your mouth and all. All are getting supply from? All are innervated by sympathetic nervous system. This blue here is all sympathetic nervous system, which is developed out of the chain of the ganglions running parallel to the spinal cord, which is also innervated by the spinal nerves. Getting my point? These are the spinal nerves. Now, I told you about another system, and that another system is related with the cranial nerves. Here are the cranial nerves. Here these cranial nerves are giving their fibers, and those are also they are also supplying to the organs, to which adrenergic nervous system is also supplying, or sympathetic nervous system is also supplying. I mean to say very simply, most of the visceral organs are supplied with adrenergic nervous system as well as cholinergic nervous system. Cholinergic nervous system is developed out of the ganglions, the cranial nerves we call them, and some sacral nerves, S2, S3 and S3. S2, S3 and S4. Some of the sacral nerves and the cranial nerves, some of the cranial nerves. They constitute this system. That system is known as parasympathetic nervous system. That system is known as cholinergic nervous system. Parasympathetic nervous system is equal to cholinergic nervous system. If you understand this, you will understand the whole lecture. If you don't understand this, nonsense. Nothing will happen. Now, point is very important. We'll take the very simple example of heart. And one point you know in it, that is adrenaline increases the heart rate. That is what everyone knows. Am I right? My dear students, this adrenaline is adrenergic stimulant. Sympathetic. Adrenaline is sympathetic stimulant, increases the heart rate. Now I am having another drug which can block this activity, and that is propranolol. Propranolol block this activity. Propranolol is going to block the adrenergic nervous system. It's an adrenergic blocker. Beta adrenergic blocker is the name. It will decrease the heart rate. What I mean to say is very clear. A drug which is going to stimulate this system increases the function of the organ concerned. The drug which is going to stimulate this system is going to increase the function of the organ concerned. Are you with me? Everyone is with me? You are with me? Now, a drug which is going to inhibit this system is going to decrease the function of the organ concerned. Propranolol decreases the heart rate. Everyone is with me? Now, acetylcholine, which is not used as a drug, it's only pharmacological tool. But if you use acetylcholine is a parasympathetic stimulant. Acetylcholine is a parasympathetic stimulant. It's a cholinergic stimulant. Parasympathetic means cholinergic. It's a parasympathetic stimulant, it's a cholinergic stimulant, decreases the heart rate. This is a very important point. When the parasympathetic nervous system, when the cholinergic nervous system is stimulated by some drug, the function of the organ concerned decreases. The function of the organ concerned decreases. Acetylcholine decreases the heart rate because it is cholinergic stimulant, because it is parasympathetic stimulant. Are you with me, my dear students? Now my next point is important. A drug which is going to block the parasympathetic nervous system, a drug which is a cholinergic blocker, going to increase the function of the organ concerned. If a drug is going to block the parasympathetic nervous system, a drug which is going to block the cholinergic nervous system will increase the function of the organ concerned. Atropine is a cholinergic blocker. Atropine is a cholinergic blocker, increases the heart rate. Atropine is a cholinergic blocker. If you understand these examples, you can keep this thing very perfectly in your mind. Are you getting, dear students? You all people are getting my point? I am going to repeat. Acetylcholine is a cholinergic stimulant. Acetylcholine is a parasympathetic stimulant, decreases the heart rate because principally parasympathetic nervous system or cholinergic nervous system is inhibitory in its function. And that's why stimulation of that system decreases the function of the organ concerned. Clear to everybody? The drug which is going to block parasympathetic nervous system, a drug which is going to block cholinergic nervous system, very simple, cholinergic blocker, will increase the function of the organ concerned. Will increase the function of the organ concerned. The best example is atropine. Atropine is a cholinergic blocker, increases the heart rate. Getting my point? Yes. Sympathetic stimulants and cholinergic blockers in one way act similarly on the heart. Are you getting? Adrenaline and atropine. Adrenaline is from adrenergic stimulants and atropine is from cholinergic blockers. Both of them are going to increase the heart rate. Everyone is happy with my words? This is a fundamental lecture, very fundamental thing I am going to tell you. You must understand this concept. See, dear student, concepts are very important. Otherwise, you may not be able to understand the things properly. Especially in cardiovascular system, it is really important. The people do not, they hesitate to use the drugs from this CVS. Many general practitioners even don't know how to control the blood pressure and they send the patient to the higher center. Are you getting my point? Yes. Few of them are very aggressive. They treat every kind of patient but don't know the basics. Those are more dangerous. नाही समजा असं पण काही लोक आहे ज्यांना कळत काही नाही, माहिती आहे तिकडे कुठेतरी हॉस्पिटल काम करतात, तो डॉक्टर काय करतो ते बघितलेलं असतं, तेच औषधं देतात. हा जास्त रिस्की माणूस आहे कारण त्याला माहितीच नाही. अभिमन्यू, फुल अभिमन्यू आहे. ही नोज आज कसं शिरायचं, बाहेर खरं जायचं माहीत नाही आहे. मला एवढंच म्हणायचं आहे तुम्हा पोरांकरता की हे सगळं समजवून घ्यावं आणि मग आपण निर्धास्तपणे औषधं देऊ शकतो. कारण आपल्याला माहिती आपण नेमकं औषध कशाकरता दिलं आहे, आपलं औषध कसं काम करणार आहे आणि हेही कळतं की बाबा यांनी घोटाळा झाला तर काय करायचं आहे. Suppose your drug is going to do something wrong, you know how to intervene then because you know the basics, and that's why basics are important. Hope so all of you like the given explanation. Should I proceed, my dear students? This figure is really very important. Adrenergic nervous system. Sympathetic nervous system is also known as adrenergic nervous system. This is what I told you. It is generally stimulatory in its function. That is, if some drug stimulates this system, that is sympathetic nervous system means adrenergic nervous system, the function of the organ concerned will be increased. And if some drug depresses the system, the function of the organ concerned will be decreased. It is very simple for adrenergic. It is very simple for adrenergic. Stimulation increases the heart rate, depression reduces the heart rate means the function of the organ concerned. We take heart because it is very easy to understand. Adrenaline is an adrenergic stimulant. Administration of adrenaline increases the heart rate. Agree with me? Yes. On the other hand, propranolol is an adrenergic blocker. Propranolol is an adrenergic blocker. Administration of propranolol decreases the heart rate. Clear to everybody? Cholinergic nervous system. Parasympathetic nervous system is also known by the name cholinergic nervous system. It is generally inhibitory in its function. That is, if some drugs stimulate the system, the function of the organ concerned decreases. When you stimulate the cholinergic nervous system, function of the organ concerned decreases. Yes. And if some drug depresses the system, the function of the organ concerned will be increased. Acetylcholine is a cholinergic stimulant. Acetylcholine is a cholinergic stimulant. It decreases the heart rate. Are you with me? On the other hand, atropine is a cholinergic blocker. It increases the heart rate. Everyone is with me? Everyone is with me? Yes. Atropine is a cholinergic blocker. Increases the heart rate. When you block the cholinergic nervous system, the function of the organ consult will increase. Opposite to that of sympathetic system or adrenergic nervous system. Exactly, everyone is happy with the words? Now, acetylcholine is not a drug, it's a pharmacological tool only. आम्ही एक्सपेरिमेंट्समध्ये वापरतो ॲसिडलकोलाईनला. ॲसिडलकोलाईन हे औषध म्हणून मार्केटला मिळत नाही. औषध म्हणून त्याचा उपयोग नाही आहे. इट इज नॉट अ मेडिसिन, बट इट्स अ फार्माकोलॉजिकल टूल. Thus one can say that adrenergic and cholinergic nervous system are antagonistic in their function. 36 चा आकडा आहे त्यांचा. 36. Getting it? They are opposite to each other. And this is how you maintain your hemostasis. You maintain your body functions. Are you getting my point? Yes. The adrenergic receptors are divided into two types, alpha and beta. The adrenergic stimulants are divided into alpha and beta. तिथे बसणं थोडं टाळ. तो मागे बेंच तुझा तिरपा झालेला आहे, तो खाली येणार नाही असं नाही म्हणता येत. नाही समजलं मी काय म्हणालो? म्हणजे मला वाटते भीती म्हणून, कारण मला येतील ना पोलीस पकडायला. जोशा, मुलांना कुठे बसवलं तू? Now again, the adrenergic receptors are divided into alpha and beta. Alpha is subdivided as alpha 1 and alpha 2. Getting it? Yes. And beta is subdivided into beta 1, beta 2 and beta 3. Beta 3 वर थोडं कम झालंय, फार नाही. Getting my point? Yes. Now, these are from adrenergic nervous system. We are studying adrenergic nervous system. From where it came? That I am going to tell you. We started with nervous system. Then we found CNS and ANS. Then we further studied ANS. ANS further will give you adrenergic and cholinergic. And now further we are studying adrenergic. This is the way we came. Are you getting my point? Now I want to study adrenergic. I am going to tell you what is the name of the chapter? Adrenergic stimulants. We are here. I feel it very necessary for the student to give you the basics first, so that you will understand it more properly. And confidence is again an important thing that develops out of that basics only. दूसरा जो confidence असतो तो बिनकामाचा आहे. This is adrenergic receptor, alpha and beta. Beta, alpha 1, alpha 2, beta 1, beta 2 and beta 3. Getting my point? Yes. Now, alpha activity divide करायची ऐवजी common alpha activity आपण घेतो. म्हणून तिला अल्फा ॲक्टिव्हिटी म्हणायचं. काय म्हणायचं? अल्फा. त्याला कारण आहे, ते सांगू का? हा अल्फा 2 जो आहे ना, हा अल्फा 2 प्री सायनॅप्टिक आहे. प्री सायनॅप्टिक आहे आणि तो काहीसा इनिबिटरी पण आहे. म्हणजे कसं सांगावं की नाही प्रश्न आहे मला, पण सांगतो. हे एक नर्व एंड आहे आणि हे दुसरं नर्व एंड आहे. माझी चित्रकला खतरनाक आहे. आता इथून एखादा न्यूरो ट्रान्समीटर सिक्रेट झाला, मी मुद्दाम मराठीतनं बोलतोय सगळं. हा न्यूरो ट्रान्समीटर सिक्रेट झाला तर अल्फा 2 इथे लोकेटेड आहे, त्याच्यावरच लोकेटेड आहे. आता विचित्र प्रकरण असं आहे की हा बाबा खाली आला की याने खरं याच्यावर काम करणं अपेक्षित आहे, बरोबर की नाही? पण याचं स्टिम्युलेशन चालू आहे, हा येतोच आहे. याने किती वेळ यावं हे ठरवावं लागेल. आणि म्हणून इथे जी संख्या तयार होते कोणाची? न्यूरो ट्रान्समीटरची, जी पुढच्या याला, हे त्याचे रेग्युलर रिसेप्टर्स आहेत, हे पुढे जाऊन स्टिम्युलेशनचं काम करणार आहेत. हे त्याचं खरं काम आहे. कोणाचं? न्यूरो ट्रान्समीटरचं. तो एका एंडपासून दुसऱ्या एंडला चालला आहे, पण त्यातले काही मॉलिक्युल्स याच्यावर जाऊन चिकटतात. आणि हा मग पुढचा रिलीज थांबवतो आणि म्हणून तो अल्फा 2 जो आहे तो ऑटो रेग्युलेटरी म्हणतात त्याला. तो हे ठरवतो की यांनी जायचं की नाही आणि ते मॅक्सिमम अल्फा 2 तेच आहेत. म्हणून ती अल्फा ॲक्शन कॉमन ॲक्शन म्हणतो आपण. म्हणजे अल्फा 2ला डिटेलमध्ये जायच्या ऐवजी, कारण ते असं रेग्युलेटरी येते ॲक्शन, हे बाकीच्या ज्या ॲक्शन्स आहेत या पुढे कॅरी करणार आहेत. तुम्हाला कळतंय का मला काय म्हणायचं आहे? तो ज्या नर्वमधनं तो तुझा न्यूरो ट्रान्समीटर येतोय त्याच नर्ववर तो असतो आणि तो काय करतो, तो इन्हिबिटरी इम्पल्सेस पास करतो आतमध्ये जेव्हा तो ऑक्युपाय केला जातो. तो केव्हा ऑक्युपाय होतो, ज्या वेळेला सिग्निफिकंट अमाऊंट ऑफ न्यूरो ट्रान्समीटर सायनॅप्समध्ये असतो. आणि म्हणून त्याला अल्फा 2ला काय म्हणतात, ऑटो रेग्युलेटरी म्हणतात. काय म्हणतात, ऑटो रेग्युलेटरी. तुम्हाला एक गंमत सांगू का? नको नको, गंमत मेजर गंमत होईल. You got it now? You just remember now, if you don't understand all these things, you just remember alpha 1 is the activity of alpha, or alpha activity is a combined activity. Let's see. Now alpha 1 and alpha 2 both are responsible for cutaneous vasoconstriction and therefore they rise the TPR.